A very simple concept, midpoint theorem based on the properties of triangles. Now, first of all, before you start with midpoint theorem, just write down a point M is said to be the midpoint. A point M is said to be the midpoint of a line segment AB if M is a point on the line segment and AM equals to MB. So if this is the line segment, this is point A and this is B, AB is the line segment, and in between we take a point M, where M is the midpoint, that is the distance from A and the distance from B is the same. So if AM and MB are equal, then we say M is the midpoint of the line segment AB. So please note it down. Now a line through M through M other than the line segment AB a line through M other than the line segment AB is called the bisector of the line segment AB. Is called the bisector of the line segment AB. So if we draw another line which is passing through the point M other than this line, supposing if we draw a line, this one, L, then L will be called as the bisector because this line bisects the line segment AB at the point M. So L can be referred to as the bisector of AB. Now you have studied many properties of a triangle as well as that of quadrilaterals. Now let us today study another result which is related to the midpoint of the sides of the triangle. So if you have noted it down, we will rub this and we will start with the definition of the midpoint theorem. So let us now perform the following activity. We will write the midpoint theorem. The line segment joining the midpoint joining the midpoints of two sides of a triangle. Two sides of a triangle is said to be parallel to its third side and is also half the length of the third side. Half the length of the third side. Now let us illustrate this with the diagram. So according to the definition says if this is the triangle ABC, the line segment joining the midpoints of two sides of a triangle. So let us take the midpoints of AB and AC as D and E. So the line segment joining the midpoint, so we join D and E. So D is the midpoint of AB, E is the midpoint of AC. So the line segment joining these two midpoints D and E is said to be parallel to the third side. So this line and this line becomes parallel, and the length DE is half the length of BC. That means we have DE is parallel to BC and DE is equals to half the length of BC. So if a line segment is drawn by joining the midpoints of any two sides of a triangle, then this line segment DE becomes parallel to the side BC, that is the third side, and the length of DE becomes half the length of BC. Supposing that the length of BC is 10 cm, then the length of DE will be just the half, that is 5 cm. At the same time, DE is parallel to BC, then this angle and this angle becomes equal, they become congruent and corresponding angles, and this angle also become equal because they are corresponding angles by the property of the parallel lines. So this is the midpoint theorem. The line segment joining the midpoints of two sides of a triangle is said to be parallel to the third side and is also half the length of the third side. Now we will proceed to prove this theorem. The proof is important. This might be asked in the examination as well, so you must learn this, how to prove this particular theorem. So proof. Let us draw the diagram first. ABC. This is D and this is E. So this is the triangle ABC where D and E are the midpoints of the sides. So what is given, first you note down. Given is D is the midpoint of AB and E is the midpoint of AC. RTP DA parallel to BC and DE is equals to half of BC. So we are given that D is the midpoint of AB and E is the midpoint of AC, and we are required to prove that DE is parallel to BC and DE is equals to half of BC. So here we will do a little construction in order to prove this particular theorem. So write down construction. The construction is that extend the line segment DE and produce it to F. Produce it to F such that DE and EF are same. Join C to F. The construction is extend the line segment DE and produce it to F such that DE equals to EF and then join C to F. So you write down extend the line segment DE and produce it to F such that DE is equals to EF and then join C and F. So a little bit of construction we have done. So since this is a construction, extra construction, we mark it dotted lines. So this is the construction we have done. Now we will proceed to prove that D is parallel to BC and D is half of BC. So if you have, please note it down. The information given, D is the midpoint of AB, is the midpoint of AC. Required to prove D is parallel to BC and D is half of BC. Construction, extending this line D till F such that this part DE and EF are equal, and then join C to F. Now we will proceed to prove this. Now in triangle AED and triangle CEF, we need to prove these two triangles congruent. So what are the things which you can take? We have AE equals to EC, that is given because it is the midpoint. AE equals to EC. We can write, given this angle AED, angle AED is equals to angle CEF, vertically opposite angles. And also DE equals to EF by construction. So we can see that triangle AED and triangle CEF are congruent. Therefore, triangle AED is congruent to triangle CEF, and the criteria here is side angle side. SAS rule. Now that we have proved that the two triangles are congruent, what we can say is that AD equals to CF, CPCTC. So we can write AD is equals to CF, CPCT, corresponding parts of the congruent triangles. AD equals to CF. Now we also know that AD is equals to BD because this is the midpoint. So AD equals to BD, it is given. So from these two, we conclude if AD equals to CF and AD equals to BD, then we can write BD is equals to CF, that BD is equals to CF. Since AD equals to CF by CPCT and AD equals to BD, so you can say BD is equals to CF. Now one more criteria, this angle is equals to this angle, angle DAE is equals to angle ECF. Again we write CPCT. This angle, if you consider these two triangles, then this angle and this angle are equal because of CPCT criteria. Now if you see these two lines and this is acts as a transversal and these two are equal, we can say they are equal because interior alternate angles. So what we can say that AB is parallel to CF. So therefore AB is parallel to CF. AB is parallel to CF means BD is parallel to CF. BD is parallel to CF. Now we have BD is parallel to CF and BD is equal to CF, that means this is a parallelogram, hence this, therefore BCFD is a parallelogram. And by the property of parallelogram we know that opposite sides are equal and parallel. So obviously if BCFD is a parallelogram, then DF is parallel to BC. DF is parallel to BC, or you can say DE is parallel to BC, or you can say DE is parallel to BC. So the first part of this is proof that DE is parallel to BC. Now we need to prove that DE is half of BC. Now you see, E is the midpoint of DF, as in the beginning only we have told that we extend this line DE till F such that DE equals to EF. So DE and EF are equal, so E is the midpoint, that means DE is half of DF. So DE is equals to half of DF. And since this is a parallelogram, so BC and DF are equal, so we can write equals to half of BC. So this proves our theorem. So we start right from the beginning once again. We take the triangle ABC. Given condition is D is the midpoint of the side AB, E is the midpoint of the side AC. Now join the points D and E. So this line segment is now extended till F in such a way that this part DE and EF are equal. Then we join the point C to F. So this completes our figure. Now in triangle AED and CEF, these two triangles, we need to prove they are congruent. This side and this side are equal because E is the midpoint. This angle and this angle are equal because they are vertically opposite angles, and this part and this part are equal, that is by construction we have taken it like that. So these two triangles becomes congruent. So once these two triangles becomes congruent, so automatically AD and CF becomes equal because CPCT property, and AD and CF are equal, and AD and BD are also equal because this is the midpoint. So you can say BD and CF are also equal. So if BD and CF are equal, so we have angle also at the same time, angle this one DAE and ECF, these two angles are also equal by this CPCT property. And if you consider these two lines and if these two angles are equal, then we can say that this line and this line are parallel because these are interior alternate angles. So now that AB becomes parallel to CF, we can say BD is parallel to CF. So BD is parallel to CF, we have got, and if BD is parallel to CF and BD is equal to CF, so this is a parallelogram. So once we have proved that this figure BCFD is a parallelogram, then opposite sides as well are parallel, at the same time are equal as well. So you can say DF is parallel to BC, so DE is parallel to BC. So we have the first condition, D is parallel to BC. Again, DE is half of DF and DF is equal to BC, so we write DE is half of BC. So this proves our theorem. Just have a look, and this proof is very simple. You need to just prove that the two triangles are congruent. So the property of congruency is applied here, which you have just recently done with. So this is the midpoint theorem. Now we will proceed to prove the converse of this midpoint theorem. So if you have written it, I will just rub the board and will write the definition for the theorem number 2, that is the converse of the midpoint theorem. Can I rub the board now?
Yes, sir.
Okay. So we can write it as converse of midpoint theorem. So first let us write down the theorem. The straight line drawn through the midpoint of one side of a triangle parallel to another bisects the third side. Bisects the third side. So this is the definition of the converse of midpoint theorem. The straight line drawn through the midpoint of one side of a triangle parallel to another bisects the third side. So this goes like this. If this is the triangle ABC, what we are given in this particular theorem is that if D is the midpoint of the side AB, the midpoint of this side is not known to us. Only thing what is given is if D is the midpoint, and starting from the point D, if we draw a line parallel to the third side BC, if we draw a line parallel to BC, if this is parallel to this and these are equal, then automatically this point E becomes the midpoint of the side AC. Am I clear? If D is the midpoint of the side AB and from the point D we draw a line, we construct a line from D parallel to the side BC. So drawing a line from the point D parallel to BC meets the opposite side AC at E, then E becomes the midpoint of AC. So this is the converse. Now we will also proceed to find what the proof of this particular theorem. So if you have noted it down, I just simply rub the definition. So let us now draw the diagram. Suppose this is the triangle A, B, C. Let us take this point D, the midpoint of AB, and from here we draw a line parallel to BC. This line are parallel, this is meeting at E. Now here also we need to do some construction. So first of all we write down what is given here. What is given? D is the midpoint of AB and DE is parallel to BC. So what we are required to prove is E is the midpoint of AC. E is the midpoint of AC. So here also we need to do a little construction. Here also what we do is we draw CF parallel to BA. From here we draw a line from C parallel to this. So this line and this line in parallel, and this we extend it till, suppose this is F. So what information is available here, that D is the midpoint of AB and DE is parallel to BC. We have to prove that E is the midpoint of AC. Now here the construction goes like this. From C we draw a line parallel to BA. So this line and this line are parallel to each other. And supposing parallel, and we extend this line DE till it meets the line at F. Right? So this is the condition. Now again we will go by the same method, proving that this triangle and this triangle to be congruent. But before that, what we see here is we have BD equals to AD, given BD equals to AD and BD is also equals to CF. Is it? If this part and these are parallel, so obviously this becomes a parallelogram. Now we have to first prove that BCFD is a parallelogram. So let us write it down. BCFD is a parallelogram. And why BCFD is called a parallelogram? Because BC is parallel to DF. BC is parallel to DF, and what else is parallel? BD is parallel to CF by construction. Right? So we have BC, this we have according to the theorem, this line is parallel to this, and by construction we have drawn this parallel to this, so opposite sides are parallel, hence you can call that BCFD is a parallelogram. So we have BD equals to CF, therefore we have BD equals to CF and AD equals to BD, given AD equals to BD because D is the midpoint. Then from these two, what we can write, AD equals to CF. AD and CF now becomes equal from this particular information. Now we proceed to prove that the two triangles are congruent. So in triangle AED and triangle ECF, what we have, this angle and this angle are equal. Angle AEC equals to angle CEF. We can call it vertically opposite angles. We can call it vertically opposite angles. Angle DAE, this angle and this angle are also equal, right? So angle DAE equals to angle ECF. So we have angle DAE equals to angle ECF. Why? Because interior alternate angles. And what else we have? AD equals to CF from here. AD equals to CF, proved above. So once,
sir,
yeah, tell.
So the vertically opposite angle would be AED.
AEC, okay, yes, yes. Yeah, AED, right, thank you. AED equals to CEF. Now these two triangles are congruent by angle side property. Angle side. So therefore we write, therefore triangle AED is congruent to triangle just change the name, CEF, you write it like CEF, same thing, triangle CEF. So triangle AED is congruent to triangle CEF, and this is by angle side rule. So now that we have proved that the two triangles are congruent, so now we can very easily tell that AE is equals to EC. So therefore AE is equals to EC, and that is by CPCT. Therefore E is the midpoint of AC. So finally we can say that the straight line DE passing through the midpoint of AC is the bisector of AC at the point E. In the beginning we have discussed about what is called midpoint and what is the bisector of the side. So any other, this is the line AC and E is the midpoint of it. The definition of the midpoint in the beginning we have done, and DE is another line which passes through this midpoint, so this is called the bisector. So DE is the bisector of AC. So this is the converse of the midpoint theorem. Now if we combine these two, if we generalize this, see what the midpoint theorem says and what the converse of the midpoint theorem says. So the midpoint theorem says if we join the line segment which joins the midpoints, if suppose this is the midpoint, is also the midpoint. So the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and half of the third side. And second case, converse theorem, if we draw a line from the midpoint of any one side of a triangle parallel to the other, it bisects the opposite side. So these are the two theorems, and if you have understood, we'll just proceed further to solve a few problems based on it, which will give a clear concept of how to go for the application of these two theorems, midpoint theorem and the converse of the midpoint theorem. So if you are finished writing, we'll take some questions on the board.
Sir,
Yeah,
sir,
tell.
sir, can I know the meaning of RTP?
RTP. Required to prove what we are going to prove. Okay? Required to prove. You can simply write also to prove. So let us now take the first question on this particular concept. Question number 1. In the given figure, AB equals to 8.4 centimeter, PR equals to 5 centimeter, PQ is equals to 4.8 centimeters. Then find the lengths of BC, CA and QR. So let us draw the diagram here. This is the triangle ABC. We have this is P, this is Q, and this is R. P is the midpoint, Q is the midpoint, and R is also the midpoint. So this is the diagram. So let us join this. So we have to apply the midpoint theorem here and need to find the following information. We are given the length AB. This side is 8.4. PR is given to be 5 centimeters and PQ, this segment is given as 4.8 centimeter. Lengths of the sides BC. You have to find the length of BC, CA, this one, and QR, this part. So if P is the midpoint and R is the midpoint, as I have told you, P, Q, R, all three are the midpoints of their respective sides, A, B, B, C and CA. So P is the midpoint, R is the midpoint. Then PR will be parallel to BC and PR is equal to half of BC. So P, Q, R are the midpoints of AB, BC and CA. Now PQ. First thing we need to find BC. So P and R, PR is parallel to BC and PR equals to half of BC. Or you can write BC is twice of PR. So 2 into the value of PR is 5. So that is 10 centimeter. Very simple. PR is half of BC, or you can say BC is double of PR. So double of PR becomes 10 centimeter. So BC we have found. Then we need to find CA. CA. If we talk about P and Q, they are the midpoints. So PQ will be parallel to AC and PQ will be half of AC. You have to find CA. So PQ is parallel to CA and PQ is equals to half of CA, or you can say CA is equals to twice of PQ, that is 2 multiplied by, now what is PQ? 4.8. So it becomes 9.6 centimeter. So CA is coming to 9.6. Now we are also given, we have to find QR, this part. Now Q and R are the midpoints of the sides BC and CA. So we have QR parallel to AB and QR is equals to half of AB. And since you have to find QR, that is the half the length of AB, and AB is given as 8.4. So this is half into 8.4, and that is equals to 4.2 centimeters. So by applying the midpoint theorem, we have found all the three unknown quantities of the parts BC, CA and QR by simply applying the midpoint theorem, that is the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and is half of the third side. So only this particular concept is used here to get the desired output. Hopefully it is clear, and we move on to the next question, that is question number 2. So question number 2 comes like this. In triangle ABC, D is the midpoint of AB and E is the midpoint of BC. E is the midpoint of BC. Calculate number 1 DE if AC equals to 6.4 centimeter and number 2 angle DEB if angle ACB is equals to 63 degrees. So let us draw the diagram first. This is the triangle ABC. We are given D is the midpoint of AB, so let us take it as D, and E is the midpoint of BC, so this is the point E. So let us join these two. So since D and E are the midpoints of the sides AB and BC, so now we can write that DE is parallel to, so this becomes parallel to the third side AC, and DE is equals to half of AC. Now let us see what we have to find in the question. We have to find the value of DE. So now according to the theorem, DE is half of AC. AC is given to be 6.4. So this is equals to half into 6.4, that is 3.2 centimeters. And also at the same time we have to find angle DEB. This angle we have to find. And we are given angle ACB equals to 63. Now that by the midpoint theorem we know that DE is parallel to AC. So if this angle is 63, this angle will also become 63, and because they are corresponding angles, so we can write angle DEB is equal to angle ACB is equals to 63 degrees, and in bracket you write corresponding angles. So this is question number 2. Just it is simple, the two questions just giving an idea about the application of the midpoint theorem. Then moving on to the next question, we have question number 3. So let us take the question number 3. In triangle ABC, M is the midpoint of AB. M is the midpoint of AB, and a straight line through M and parallel to BC cuts AC in N. Find the lengths of AN and MN if BC is equals to 7 centimeters and AC is equals to 5 centimeters. So before you can solve this, let us first have the diagram here. In triangle ABC, if this is a triangle ABC, M is the midpoint of AB. So M is the midpoint of AB and a straight line through M and parallel to BC. So from M we draw a line parallel to BC which intersects this line AC at N. So this is the converse of the midpoint theorem. You can very easily find out. M is the midpoint and from M we draw a line parallel to BC which intersects the side AC at N. So these two sides become parallel. So N becomes the midpoint of AC. So now we have to prove. So M and N are the midpoints. So Mn becomes half of BC and is also parallel already given. So find the lengths of AN. Now since N becomes the midpoint by the converse theorem, so AN is equals to half of AC, converse theorem. So that is half of AC is given to be 5, so that is 2.5 centimeter. Next you need to find the value of Mn. So Mn equals to half of BC and that is half into 7 and that is 3.5 centimeters. So here we got the values. An is 2.5 centimeter which is half the length of the side AC and Mn is 3.5 centimeter which happens to be the half of the side BC. So this is question number 3. Now what is the time today? Almost it is. I just will write the question on the board. You solve it and we will ask it in the on the next day. So question number 4. Prove that the figure obtained by joining the midpoints of the adjacent sides of a rectangle is a rhombus. So the question here is prove that the figure obtained by joining the midpoints of the adjacent sides of a rectangle is a rhombus. So what is important here is the previous knowledge. Now what type of figure is a rectangle and what are its properties. What type of figure is the rhombus and what are its properties, you must know in order to prove questions of this category. So the properties are very important. If you don't know, please go through that. Find in the chapter quadrilaterals, you will find the properties of the quadrilaterals, so the different figures, the rectangle, the square, the rhombus, trapezium, kite, everything you will get the properties of those quadrilaterals. It is very important for you to know at least to prove questions like this. If you don't know and if it is required in the question, you will be stuck in between. Now according to this question, prove that the figure obtained by joining the midpoints of the adjacent sides of the rectangle, if these are the midpoints, and if you join these midpoints, now suppose if you take it as ABCD, the rectangle ABCD, and PQRS to be the midpoints of the sides AB, BC, CD and DA. So we need to prove that PQRS is a rhombus. Now first of all, a rhombus is the one whose all the sides are equal. This is one property. Second property is that the diagonals bisect or intersect at right angles. That is the very crucial property of rhombus. So you have to take care of, or simply if you can prove that the four sides are equal, we can prove that. So this question I leave it to you. A little bit of extra construction may be required to do in this particular question. So go through the solved examples.
Sir?
Yeah.
So we can join BD and AC.
Yes, that is what I am telling you. A little bit of extra construction may be required in proving this particular question. So if you join AC and BD, and then you can prove by taking the triangles and applying the midpoint theorem, you can get the final result. So today, since the time is over, I leave this question for you, and the next class will take up more questions to give us a clear idea about the application of the midpoint theorem. Okay, so if anyone joining for the first time today's class, so as I tell you, the recording of the class will be available in this. In the YouTube channel. So if you are to refer to this particular class, today's class, the recording will be available in YouTube, so you can go to that particular channel and can have a look on this. So those who have joined late or those who are new for the first time, you have joined class, so you can go through this, and those who are already in the group and those who know, so you can also go through this and you can find out that if you require to go through. Anyway, so that's all for today. So enjoy yourself. Have a nice day.
Thank you, sir.
Thank you.